to 0. So you can have 2ay, because dy is also equal to ay, right? This will be equal to 20 times 10 to the power 3. So ay is equal to 10 times 10 to the power 3 Newton. Okay, and this is also equal to dy. Now, if you don't know this, okay, just do the standard thing. Okay, if you are not aware of this rule, okay, or you're panicking because of term test, we also can do this. So this is 0.15. The distance from here to here is 0.25. And the distance from here to here is 0.15. Okay. So if you don't know that rule, we can do option or alternate method. Okay. We just do summation about moment in the z direction at point A is equal to 0. So we're going to take moment at this point over here. Okay. So you have going in a clockwise, so minus 10 times 10 to the power 3 multiplied by 0.15 minus by 10 times 10 to the power 3 multiplied by 0.4, right? So 0.25.4, then plus by dy, or plus by what? 0.15, 0.3, 0.55. The whole thing will be equal to 0. Okay. So 10 power 3 times 0.15 is equal to minus 1500 minus by 10 power 3 times 0.4, 4000, plus by 0.55 dy is equal to 0. So dy is equal to 5500 divided by 0.55. Okay, so 5500 divided by 0.55 is equal to 10 times 10 to the power 3. Then you do positive summation about forces in the y direction is equal to 0. You have ay minus by 10 times 10 to the power 3 minus the second times 10 to the power 3 plus by 10 times 10 to the power 3. The whole thing is equal to 0. Ay is also equal to 10 times 10 to the power 3. Okay, if you don't have the confidence in the left-hand side, do the right-hand side, answer will be the same. Does not matter. The most important thing, get the right answer. Okay. What if one of the load was bigger than the other? What's he doing now? Thanks. Okay, as long you answer one to the other. Wait, let me see. What if one of the load? Yeah, if the one of the load is bigger than the others, then this will not work. Okay. Okay. So from here we are going to find. Okay. Say it again. Yeah. Then you cannot use this. Then you have to use this. Okay. So the question asks, like what is asked online, if the loading condition are not the same, okay, this technique will not work. Okay. So now we are going to find the maximum bending halfway at the center. So we're going to find the maximum bending at this point over here. Okay. So I'm going to call this at our point F. Okay. We're going to find right. So I'm not going to form the shear force and bending moment equation from now. You know how to do that already. We're just going to directly find at point F what's going on. Okay. So we're going to draw this now. So now, this is point A. Then we have our point B. And over here is our point F. Okay. So over here, you have 10 times 10 to the power 3. Distance from here to here, it is 0.15 plus by 0.25 divided by 2. So 0.275. Right? Because it's 0.15 plus by 0.25 divided by 2. Right? So we know that there's another load coming down here. Right? This is 10 times 10 to the power 3. And then we know the distance from here to here, it is what? 0.15. So the distance from here to here is 0.275 minus by 0.15 is equal to 0.125. Okay. So we know, right, or we can assume positive bending and positive moment. So we call this M at point F. Okay, moment at point F. That's our counter moment. Okay. So what we have done now, if you focus on this diagram now, I'll let you finish copying first. Okay, I'll let you finish copying first.
So just one question.
Yes.
So we are just taking half of the portion because it's symmetrical loading, right?
Yes.
But if there is no symmetrical loading, then we can't take half. We have to take the whole body, right?
We are taking the whole body because the maximum bending moment occur at point F.
Okay.
Right?
Okay.
If you look at this diagram over here, right?
Yes.
Whether you take this side or
Hmm.
the other side, maximum is still PL over 4. Yes?
Yes. Yes.
Yeah. So when I was young, I was so confused. Why only look at half of it? Right?
Okay. Okay. Okay.
Now I understand. You understand or no? Are you okay or no?
Yeah, I'm okay with that now. Yeah.
Yeah, I was blind for 46 years and now I can see, you know?
Yeah. Yeah. Makes
Okay, I
sense.
want you to see when you are young. Don't be like me. Objective is to make you better than me at a younger age. Yes?
Yes,
Then
sir.
you can pay for the gas price.
Yeah.
Yes? Okay, good. It cannot, this cannot use. Huh? Then you cannot use this. You have to you have to form the equation for the entire shear force and bending moment diagram. Okay, for now, most of the loading condition you see is going to be symmetry. Okay, later on, week 10, then no more rigid body assumption. Remember rigid body? Deformation, no more. We're going to take that out and no more symmetry. We're going to take everything out. And that's where, yeah, it gets a bit complicated, but not impossible. Okay, so now we are going to analyze there. Okay, moment at point F. So we are going to do static. So okay, if you look at this diagram now, and before we were drawing a lot of this type of diagram, right? This is on page 3. Okay, I'm going to paste. Okay, so if you look at all this diagram, it's similar, yes or no? Nothing changed. This is what we have just drawn. This is what we have before. Right? It's very similar, but now the numbers are what? Different. Yes or no? Okay. So coming back to here, we're going to find a moment. So we are going to carry out on static analysis. Okay. So I mentioned about moment in the z direction at point F, everything is equal to 0. Okay. So the 10 times 10 to the power 3 is going in anti-clockwise, in the clockwise. So 10 times 10 to the power 3 multiplied by 0.275. Plus by the 10 times 10 to the power 3 multiplied by 0.125. That's why it's so important to get the distance right the first time. Yes or no? Remember what I do? I draw the free body diagram and I include the what? The distance. It's important that you do that. Okay? And then the whole thing is plus m at point F is equal to 0. So m at point F is equal to 10 power 3 times by 275 minus by 10 power 3 times by 0.125 is equal to 1500 positive. Okay. So if it's positive, means this direction is okay. Okay. If later on, if you calculate it's negative, what you should do is you have to flip the direction. Are we clear? Right? If it's negative, you just switch the direction. Okay. So let's say now, okay, I'll use a different color. Now you calculate and it's negative. Right? You switch the direction here to become what? Okay, if, okay, this is a if it's negative. Now this is MF is what? Negative, and when we calculated is positive. If it's positive, what does this mean? The head of the moment vector at the top is compression, at the bottom is what? Tensile. If it's negative, right? Now it changes. This will be what? Eugene, come on, keep on being colorblind. This is compression, and this is what? Tensile. Okay, but for now, our answer over here is what? Positive. Don't use that color, you get confused. This is positive. Okay. Say it again. Yeah, the forces interaction. Or one become higher than the other. Okay. So now, anyone, any question or no? Okay. So now the next thing, once we get this, so now if we go back to our formula, okay, if we look at this formula, we found what is our MZ. Okay. Next, we need to find our centroid and our IZZ. Okay. So let's find centroid and IZZ. Okay. So I will copy the image. Pardon me. And I'll paste. And I realized while marking the term test, you also have, not all of you, some of you still have issue with second moment of area. Okay, I want you to have some confidence. Okay, right. So I'm going to do it two ways. Okay, I'm going to do datum at the bottom and datum at the top. Okay, so it does not matter where you take, the distance will be the same. Okay, so I'm going to divide it this way. So I'm going to call this our web 1, web 1. This is our flange. So I know you are very familiar with what's a web and what's a flange now. Okay. So the interest now that we want to find is going to be ZZ. Right? So this is our ZZ. So this direction will be our width, and this direction will be our depth. Exactly like how I taught you in shearing stress. Exactly the same. So we have section. Okay.